Today we are going to read and highlight Lesson 3 of Unit 2, Shaping Earth's Surface. If you go and look at the table of contents, you can see that Lesson 3, Reading Clues and Rocks, starts on page 24. So scroll down to page 24 or flip to that page, and let's begin. Reading Clues and Rocks, Visiting the Grand Canyon. In 1903, President Theodore Roosevelt visited the Grand Canyon. When he saw it, he said, "The Grand Canyon fills me with awe. It is beyond comparison." The Grand Canyon is part of a national park. This means that the land is available to the public. It is a popular tourist destination. Every year, more than 5 million people visit the canyon. It is one of the 7 natural wonders of the world. Many people visit the Grand Canyon to see its natural beauty and size. It also holds one of the most complete geologic records of Earth's history in its layers. Geology is the study of Earth's structure and history, as well as the processes that shape it. Studying the canyon's layers. Most of the rocks in the Grand Canyon are sedimentary rocks. Sedimentary rocks form from sediment that comes from weathering and erosion. Wind and water weather the rocks and then erode the sediment. Layers of sediment gradually build up over time. Over thousands or millions of years, the pressure of more and more top layers of sediment compresses the layers of sediment into solid rock. Because of this, the oldest sediment forms the bottommost layers of rock. Newer layers replace older layers at the top. The walls of the Grand Canyon show all the different layers of sediment that built up over millions of years. The bottom of the Grand Canyon has rocks that are more than 2 million or 200,000 million years old. Categories of rock. There are 2 other categories of rock, metamorphic and igneous. Scientists classify rocks based on how they form. Metamorphic rock forms in chemical reactions where one type of rock is changed by pressure or heat into a new type of rock with different properties. The movement of Earth's tectonic plates push rocks deep into the crust. The heat and pressure of all the weight on top of it causes chemical reactions. In a chemical reaction, the atoms and molecules that make up the substances are rearranged to form new matter with different properties. The word metamorphose means to change. It can take millions of years for a metamorphic rock to form. Igneous rocks form when hot liquid magma from Earth's mantle cools into a solid form. Igneous rocks are often found around volcanoes. The magma either cools slowly below Earth's surface or is released as lava through volcanoes. The cooled lava hardens into igneous rock. The rock cycle. Rocks do not remain the same forever. The matter that makes them up cycles and changes into different kinds of rock over time. For example, rocks break down into sediment. That sediment can collect in layers. Over time, heat and pressure can compress the layers of sediment into new sedimentary rock, or tectonic plates can push the sediment deep into Earth's crust. There it can undergo chemical reactions that change its properties, turning it into metamorphic rock. With enough time, any rock pushed deep into Earth's interior will melt into magma. If magma reaches the surface, it will cool and harden into rock again. Weathering and erosion happen to all rocks on Earth's surface. The processes that form, break down, and reform rock from one category to another are called the rock cycle. Ocean to desert. The Colorado River has weathered and eroded the rock to carve out the Grand Canyon. Because of this, we can see the different layers that have formed over time. Each layer represents a period of time, often with a different climate or geography. The land around the Grand Canyon is now a desert. This means that it is dry and does not receive a lot of rain. But studying the rock layers of the Grand Canyon shows that the ocean covered the land at least 8 times in the past. The last time the land was covered by ocean was 80 million years ago. Scientists can tell when ocean covered the land because the water left behind different types of materials each time. Those materials then hardened to become solid rock. Some of the material was sand that became tan-colored sandstone. Some was mud that hardened into darker shale. The calcified remains of marine organisms turned into light-colored limestone. How fossils form. The Grand Canyon also holds clues about past life and changing environments. This is because of the fossils held in its rock. Fossils are the remains of ancient plants and animals the traces or impressions of living things from past geologic ages or the traces of their activities. Sedimentary rock often holds fossils. As sediment built up, it often trapped and preserved remains of living things. These remains include whole plants and animals. They also include traces of organisms, such as footprints. Fossils include bones, teeth, wood, shells. Another kind of fossil is called a trace fossil. It is an imprint or evidence of a living thing left behind in rock. The trace fossil may be of a footprint or an entire organism. Trace fossils help scientists understand how and where an animal rested, moved, or fed. Footprints, worm burrows, and insect nests are examples of trace fossils. Fossils as fuels. Fossils hold stored chemical energy. Remember that all matter has chemical energy. This energy is stored in the bonds that hold atoms and molecules together. When living things die and turn into fossils, their remains store that chemical energy. Under the right conditions, heat and pressure compress all of this matter. Over millions of years, the matter can transform into coal, oil, or natural gas. The gasoline that powers your car came from organisms that lived hundreds of millions of years ago. This is why we call gasoline a fossil fuel. Fossil fuels include gasoline or oil, coal, and natural gas. When they are burned, fossil fuels release their stored chemical energy. Unlike energy in wind and water, fossil fuels are a non-renewable resource. They take millions of years to form. Scientists study fossils to learn more about Earth's history. The fossil record includes all the fossils that have ever been found, which scientists use to understand Earth's history. Because of how fossils are made, the fossils that are found in lower layers of rock are more ancient than fossils found in higher layers. Some of the oldest fossils found in the Grand Canyon are 1,200 million years old. There are also many fossils formed much later, between 525 and 270 million years ago. Many of the fossils found in the Grand Canyon are marine fossils. This means that the organisms once lived in the ocean. A common marine fossil is a brachiopod. These animals lived on the ocean floor. There are many fossils of plants, including ferns, in the layers of the Grand Canyon. Most of these fossils are trace fossils. Evidence for past changes. How could an ocean covered what is now the Grand Canyon? The answer has to do with the movement of Earth's tectonic plates. As the tectonic plates drift on Earth's magma, they change Earth's surface. For example, between 2.5 and 1.8 billion years ago, scientists believe that sediment, including sand, mud, and ash, was deposited in a marine basin. Then, at least two volcanic islands and a tectonic plate converged. This motion caused the marine sediment to get pushed upward. Over time, the tectonic plates shifted again. The rocks got buried, and more sediment was deposited on top of them. Scientists have been able to piece together this history by reading the clues in rocks. They study the properties of each of the layers as well as any fossils found. The processes that form the canyon continue today, repeating over and over. This means that the canyon is continuing to change and will likely look different in a million years from today. The locations of certain fossils around the world also show how Earth has changed over millions of years. For example, fossils of tropical plants have been found in Antarctica, the coldest continent on Earth. This evidence suggests that Earth's climate has changed dramatically over the years, and that Antarctica was probably much warmer than it is today. In the 1900s, scientists began to notice that the 7 continents fit together like puzzle pieces. They had a hypothesis that the continents were once joined together as a supercontinent. The supercontinent is called Pangaea. After studying fossils and rocks from different continents, coastlines, they found evidence for this hypothesis. Scientists found fossils of an ancient fern on the continents of South America and Africa. This was evidence that the 2 continents had been connected as part of Pangaea. Pangaea began breaking into 7 continents about 200 million years ago as the plates underneath the continents moved away from each other. Take a minute, make sure you've highlighted everything, and then move on.